Imagine being placed in a room where every wall should be filled with voices, laughter, and signs of life, but it's completely silent. That's the universe. On paper, everything screams abundance, billions of stars, countless planets, enough time for civilizations to emerge, grow, and thrive. And yet, nothing. No signals, no megastructures, nothing detectable. It's one of those mind-blowing science realities that shakes everything we thought we knew about life beyond Earth. Most of us expect that if life were common, the galaxy would feel alive. But here's the paradox: the universe isn't just quiet, it seems to be avoiding us. And that makes the story deeply unsettling. The silence itself is a signal, a puzzle, almost a challenge. In terms of space storytelling, it's as if we're intruders trying to peek behind a curtain we're not allowed to lift yet. Now, imagine standing in the middle of a gigantic city at night. Millions of apartments, endless streets, infrastructure everywhere. Now imagine every single light is off. No windows glowing, no cars passing, no sound. Statistically, that silence shouldn't happen. And yet, that's exactly how the universe feels when we look up. These are some of the most unsettling space facts and cosmic mysteries quietly beginning to surface. From a scientific point of view, expectations were high. Astronomers discovered billions of ancient stars long before the sun was born, billions of planets orbiting them, and more than enough time for life to emerge, evolve, and spread. When astronomy explained this mathematically, the conclusion felt almost obvious: intelligent life should be everywhere. These universe facts weren't wishful thinking, they were equations, probabilities, cold logic written into the fabric of science explanations. And yet, when telescopes actually listen, there's nothing. No confirmed transmissions. No colossal megastructures blocking starlight. No clear signs of advanced engineering across deep space exploration. The contrast between expectation and observation is brutal. It's one of those fascinating space facts that feels less like curiosity and more like discomfort, especially for anyone who truly enjoys space storytelling that challenges comfortable assumptions. It's like throwing a massive party and sending out billions of invitations, only to find the room empty. The silence isn't neutral, it's loud. In the world of space discoveries, silence becomes data. Every failed detection adds weight to the question rather than removing it. This is why the Fermi Paradox refuses to fade, it grows heavier with every year of better instruments and sharper measurements. Of course, science is honest about its limits. These conclusions depend heavily on probabilistic models and human assumptions. We assume other civilizations use technologies we'd recognize. We assume energy waste, radio waves, or detectable signatures. But what if those assumptions are naive? Universe explained from a human lens may be deeply biased, and the cosmos doesn't owe us familiarity. There's also a quieter, more personal layer to this paradox. When people first learn about it through space education videos, there's often excitement. Then comes a pause. Then something shifts. If life is common but intelligence is silent, maybe the rare thing isn't biology, maybe it's longevity, restraint, or survival. That's where mind-blowing science stops being abstract and starts feeling existential. The paradox may not be telling us that the universe is empty, but that our expectations are misaligned. And once that possibility sinks in, it quietly prepares the mind for a far more disturbing question, not about where everyone else is, but about what usually happens to those who get far enough to ask. The Great Filter doesn't try to comfort anyone, it explains patterns. If intelligent life should be common, then something, somewhere along the path from chemistry to cosmic civilization, must be brutally selective. In space facts and universe facts, probability stops feeling friendly and starts feeling personal. The core hypothesis is simple, almost elegant. There exists a critical barrier, a filter, that most forms of life never pass. It could be early, like the origin of life itself. It could be later, like the leap from intelligence to sustained technological civilization. When astronomy explained this mathematically, it reframed the silence not as emptiness, but as evidence of repeated failure. Scientists have proposed several candidates. Maybe life itself is incredibly rare. Maybe intelligence is the fluke. Or maybe civilizations tend to self-destruct through technology, environmental collapse, or internal conflict. These aren't sci-fi fantasies, they're extensions of patterns already visible in our own history, which makes these science explanations especially uncomfortable. Think of a marathon with thousands of runners at the starting line. At every checkpoint, most drop out, injury, exhaustion, poor preparation. By the final stretch, only a handful remain. The finish line isn't mysterious, it's selective. In space storytelling, the universe may be doing something very similar. The disturbing twist is this: we don't know where the filter is. If it's behind us, humanity is extraordinarily lucky. We already passed the hardest test. But if the filter lies ahead, in managing energy, technology, or cooperation, then the silence becomes less a puzzle and more a warning. Few cosmic mysteries hit harder than that possibility. This is where mind-blowing science quietly merges with self-reflection. Nuclear weapons, climate instability, runaway AI, these aren't abstract dangers anymore. They look suspiciously like filters in progress. In many space education videos, this is the moment when curiosity gives way to introspection, because the data stops being distant. The universe may be indifferent, letting civilizations test themselves again and again. And if most fail, the absence of signals isn't strange at all, it's expected. That realization naturally opens the door to a deeper question: what if survival doesn't just depend on power or intelligence, but on learning when not to be seen? Now, reconsider a deeply human instinct, the desire to announce presence. On Earth, visibility often means dominance, progress, or success. In the universe, it might mean vulnerability. Some space facts suggest that survival on a cosmic scale could depend less on expansion and more on discretion, a shift that feels counterintuitive but strangely logical. Any civilization that uses large amounts of energy becomes detectable. Heat leaks, electromagnetic emissions, artificial light, all of these can travel vast distances. From the perspective of astronomy explained, advanced technology doesn't just empower, it also broadcasts. In deep space exploration, detectability and exposure are tightly linked. Think of nature on Earth. The species that survive the longest are rarely the loudest or most visible. Many thrive through camouflage, silence, and restraint. A brightly colored animal may impress, but it also attracts predators. In space storytelling, this analogy resonates because evolution doesn't reward bravery, it rewards continuity. If the universe contains unknown threats, then revealing one's location could be reckless. Civilizations might learn this lesson early, long before developing interstellar travel. Cosmic phenomena don't need to be malicious to be dangerous, even unintended interactions between advanced species could be catastrophic. This hypothesis assumes universal dangers without direct evidence. Critics argue that we're projecting terrestrial fear onto a cosmic scale. Still, in many science explanations, risk management appears as a universal principle, not a human one. Avoiding unnecessary exposure is often the smartest strategy. Silence doesn't require perfect technology, it requires discipline. A civilization might actively suppress detectable signals, choosing efficiency over excess. In fascinating space facts, sometimes what isn't observed tells a clearer story than what is. Staying hidden increases survival odds, silence becomes adaptive behavior. And once that possibility settles in, a more intriguing idea begins to emerge: maybe the silence isn't driven by fear at all, but by something closer to responsibility. What if advanced civilizations aren't hiding because they're afraid, but because they've learned that interference causes harm? In space facts and universe facts, maturity doesn't always mean action, sometimes it means knowing when not to act. The core of this hypothesis rests on a familiar scientific principle: non-contamination. When studying fragile ecosystems or isolated cultures on Earth, researchers observe without intervening. In Astronomy Explained, this ethic could scale up, guiding civilizations that have already witnessed the consequences of premature contact. Think of anthropologists observing an uncontacted tribe. Revealing advanced tools or knowledge too early would collapse natural development. Even good intentions can distort outcomes. In space storytelling, this analogy feels uncomfortably plausible, especially when humanity's own history of first contact is examined honestly. This perspective reframes silence as patience. Observers may be watching, waiting for signs of stability, cooperation, or self-regulation. From this angle, the absence of contact isn't rejection, it's conditional engagement. Many space education videos touch on this idea because it transforms isolation into evaluation. Still, the hypothesis has weaknesses. It assumes a shared ethical framework across civilizations that evolved independently. It also struggles to explain total silence, no probes, no mistakes, no leaks. Cosmic mysteries rarely allow such clean explanations, and that tension keeps the idea open rather than settled. There's also a humbling implication. If we are being observed, then humanity isn't the protagonist of the universe's story, just a chapter still being written. In mind-blowing science, that shift in perspective can feel both unsettling and strangely grounding. Once you accept the possibility of observation without intervention, a new question naturally follows. What if the reason we don't hear anything is simply because we're listening for the wrong kind of signal? At this stage, we confront a humbling truth: we might simply be blind. Humanity has searched with radios, telescopes, and enormous arrays, expecting to intercept signals in ways we understand. Space discoveries often come with this assumption baked in. But what if the universe is communicating in ways we cannot yet perceive? Traditionally, scientists expected energy leaks, repeating patterns, or megastructures, signals that could be interpreted across light years. These methods made sense for a civilization using wasteful energy outputs. Yet, as astronomy explained, civilizations might be far more sophisticated than our models assume, using stealthy methods that evade our primitive detection. Consider communication via quantum entanglement, or methods that don't emit detectable radiation. In Fascinating Space Facts, this isn't pure speculation. Physics allows for it, even if we can't practically implement or observe it yet. Imagine trying to capture Wi-Fi signals with a tin can telephone. That's humanity trying to listen for these signals with our current instruments. He often uses the analogy of a smartphone trying to read smoke signals. The signal is there, perfectly valid and structured, but the device is fundamentally unsuited to detect it. In space education videos, this is a common illustration because it makes the abstract frustration tangible. Of course, some of these technologies remain theoretical, but the underlying principle is clear: the silence may not reflect absence, but rather inadequacy of our senses. Cosmic mysteries can sometimes be missed not because they are subtle, but because we're looking through the wrong lens. This perspective shifts responsibility back onto us. If we're limited in perception, exploration requires imagination as much as instruments. Every Space Facts lecture should remind us that what we don't see can be just as profound as what we do. Finally, he emphasizes a subtle but critical point: the universe may be teeming with communication, but our methods are childlike. And that naturally prepares the listener for a question even deeper: what if the timing of civilizations themselves is misaligned, leaving us out of sync with signals that exist? He often begins this segment with a thought experiment. Imagine two fireflies blinking in a vast, dark field. Both are bright, both are capable, but their flashes never coincide. That's a simple analogy for a complex reality. Civilizations may rise and fall in cosmic time, appearing and vanishing on scales so vast that overlap is rare. These space facts challenge our instinct to expect simultaneity. Stars are born, live for billions of years, and die. Planets form, atmospheres evolve, and species emerge, all on time frames that dwarf a human lifespan. Universe explained, these processes create staggering temporal gaps. A civilization that peaked millions of years ago may have left nothing behind for us to detect. Similarly, future civilizations might arise long after humanity fades. He likes to illustrate this with practical imagination. Think of historical human empires. The Egyptians, Romans, and Mayans thrived, then disappeared, leaving behind ruins for those who came centuries later. In deep space exploration, civilizations may leave faint traces, but the universe is vast, and signals degrade with time. Even a bright beacon might blink past our narrow observational window. Yet, statistical models suggest some overlap should exist. With billions of stars and planets, shouldn't at least a few civilizations coincide with us? That question forms the heart of cosmic mysteries: why the silence persists despite probable simultaneity. It's not a flaw in reasoning, It's a puzzle that forces humility in the face of fascinating space facts. He also notes a subtle human bias. We tend to assume the present moment is special, that our observation time is significant. But cosmic timing reminds us that existence is relative. The universe doesn't schedule its civilizations to match our curiosity. Space storytelling benefits here, illustrating that missing the signals doesn't mean absence, just misalignment. Finally, he hints at the existential weight. Being alone isn't necessarily permanent, but it might be temporal. Humanity could be the lucky few, or the unlucky ones, existing in a quiet cosmic gap. He closes this topic with a gentle nudge to wonder about perspective. Timing isn't something we control, yet it shapes perception, understanding, and expectation. And that naturally leads to the next idea. Perhaps the universe isn't silent by accident, but by deliberate design, testing us before revealing itself. At this point, he frames the universe almost like a patient teacher. What if the silence isn't just absence, but a challenge? In Space Facts and Cosmic Phenomena, the idea emerges that contact might only occur once certain conditions are met, not for punishment, but for evaluation. Universe Explained, it's as if civilizations must prove themselves worthy before being acknowledged. The concept is that advanced civilizations may wait for signals of maturity. Control of energy, global cooperation, ecological balance, and non-aggression could be criteria for recognition. In space storytelling, this transforms the quiet into a kind of universal examination, where the stakes are survival and ethical development rather than conquest. He often uses a classroom analogy. Imagine a teacher observing students silently, only intervening when they demonstrate understanding and responsibility. The universe could be using a similar system, evaluating each civilization's readiness before making its presence known. In deep space exploration, it's a humbling reminder that intelligence alone may not be enough. Of course, this raises questions about subjectivity. What constitutes maturity for beings whose evolution is completely alien to ours? Science explanations must wrestle with anthropocentric bias. We measure maturity by human standards, yet cosmic criteria could be utterly different. Still, the analogy helps frame the problem in tangible terms. The stakes of this test are existential. Civilizations that fail or act recklessly might never hear the answers they seek. Fascinating space facts suggest that the universe's silence could be the ultimate feedback mechanism, subtle, consistent, and quietly relentless. It's a paradox that blends space discoveries with philosophical reflection. He emphasizes that the silence itself is informative. It teaches patience, humility, and self-assessment. In space education videos, this idea is often highlighted because it encourages humanity to look inward, understanding that our behaviors could determine the cosmic response. Finally, he leaves the listener with a subtle tension. Maybe we aren't ignored because we're unworthy, but because we haven't yet shown the qualities that would merit attention. The quiet becomes both a mirror and a motivator, naturally leading to the unsettling but fascinating possibility that the silence itself carries meaning. He opens this final development block with a provocative idea. What if the universe isn't failing to communicate, but actually teaching us through silence? In Space Facts and Cosmic Mysteries, silence ceases to be absence and becomes intentional, a subtle form of messaging. Universe Explained, this perspective reframes all previous questions into a single, unsettling hypothesis. The synthesis is striking. It's not about missing signals, failing technology, or being unlucky in cosmic timing. It's not a flaw in observation or a coincidence. The silence may be deliberate, structured, and reflective, demanding that we interpret it carefully. In space storytelling, the universe transforms into a mirror, showing humanity its own readiness, or lack thereof. He often uses the analogy of a mirror that doesn't respond but reflects everything. Look closely, and you see yourself, your civilization, your choices, and your ethics. The quiet reflection forces introspection, turning fascinating space facts into a kind of moral and strategic feedback, subtly instructing rather than narrating. This raises the most existential point yet. Perhaps the greatest lesson isn't where are they, but who are we? Deep space exploration suddenly becomes an inward journey as much as an outward one. The silence, paradoxically, might be our first contact with the universe in a language we must learn ourselves. He encourages the listener to imagine how humanity might change if we truly absorbed this lesson. Would we act differently with technology, with the planet, with each other? In space education videos, posing these reflective questions often leads to the most meaningful engagement, because the universe's answer isn't explicit, it's an invitation. The limits of this idea are profound yet subtle. We can't prove intent. We can't confirm a test. Yet, in science explanations and mind-blowing science, the hypothesis is compelling precisely because it merges probability, ethics, and existential reflection into one. The silence transforms from a void into a narrative thread. Finally, he leaves the question lingering, a looping thought. Maybe the ultimate communication from the cosmos isn't a signal, a probe, or a flash of light. Perhaps it's this silence, asking us to listen, reflect, and evolve, a subtle nudge toward understanding ourselves before expecting to understand anyone else. Now, take a moment to reflect on everything we've explored. The universe isn't just vast, it's selective, patient, and, in some ways, almost pedagogical. All those space facts, cosmic phenomena, and mind-blowing science lessons aren't abstract, they're mirrors for humanity. If we want to survive and thrive, we need to look inward as much as outward, questioning our choices, technology, and the way we interact with our own planet. Think about the great filter, the silent observers, and the technologies we may not even perceive. Each is a reminder that cosmic maturity isn't about power or speed, it's about responsibility. How we manage energy, cooperation, and ethics could determine whether we ever hear the answers we're seeking. Universe Explained, the silence could be less a void and more a challenge, waiting for us to prove ourselves worthy of interstellar attention. Ask yourself, are we acting as a civilization ready to be observed? Are we ready to control our impulses, avoid self-destruction, and work collectively on a global scale? In space storytelling, these questions aren't hypothetical, they're invitations to action. What we do today, how we innovate, and how we coexist could shape whether we are acknowledged in the cosmic theater. Here's a thought experiment. Imagine the universe as a teacher, observing us quietly. Every decision, every conflict, every advancement is a test. Deep space exploration isn't just about looking outward, it's about preparing to be seen. The silence is a nudge, a challenge, and a lesson wrapped in darkness. And it's up to us to interpret it wisely. If this perspective excites you, provokes curiosity, or even challenges your assumptions, then there's more to explore. Dive deeper into space education videos, analyze cosmic mysteries, and let your imagination roam. Ask questions, debate theories, and consider the responsibility that comes with awareness. The universe may be waiting, silently, to see what we do next. Before you go, don't forget to subscribe and activate notifications to continue exploring these mysteries. And on the screen, you'll see a video ready for you, the previous one, so you can continue your journey into the profound, often unsettling, but endlessly fascinating cosmos. Fascinating space facts await, and the adventure is far from over.